I feel the need for lead. Today, we're going to talk about lead screws. Guess what I got? I got my lead screws in. We're going to talk about lead screws and we're going to cover some of the basics and some of the differences of the lead screws and how they're configured.
I'm very excited. My lead screws are here. I can get started on my build now. I still have to make the corners for my frame, but after I get that done, then I can start actually building the thing and getting it put together. So let's open it up and I'll show you what I got here. Alright, what I got here are some 600 millimeter lead screws with brass nuts. So I'm glad to finally have these. So let me tell you a little bit about what I have here. They are 600 millimeters long. They have a 2 millimeter pitch. They are a single start lead screw. And we're going to get into that a little farther. What I'm hoping to do is shed a little light on some misunderstandings for lead screws. Hopefully I've come up with a little bit of information that I can put together here for people that have not come across this topic yet and still need to understand it. I had to learn it as I was doing research for my build. I had no idea what a 1-start, 2-start, 4-start lead screw was. I knew what lead screws were. I've worked with lead screws and ball screws years ago, but I didn't know as many of the details as I probably should have. There's a little more to them than just meets the eye. So I'm going to dig into that a little bit and see if I can show some people maybe a little demonstration, an explanation of the differences between the starts. So let's see how it goes. Okay, first of all, let's get into the differences between screw threads and lead screw threads. First of all, screw threads, if you look at any nut, bolt, or screw with threads on it, you will usually see that they have a V-groove thread. It has an angled face in the thread. And they do that on purpose because the angled face creates more friction for holding power. And that's what screws and bolts are made for. They're fasteners. They're made to hold things together. You don't want the nut or bolt spinning off freely. Lead screws are designed to convert a rotational force, I guess, into a linear force. And they want to do that as efficiently as they can, and they want the least amount of friction resistance as they can get. So instead of having a V-groove thread, they have a square thread, which means the face of the thread, the wall of the thread, is 90 degrees to the axle. That gives them the least amount of friction, the most amount of holding power, and allows you to run equipment or operations smoothly and efficiently and with less friction. There is another thread in there. There's in a lot of machine equipment they call the Acme thread, which is kind of a hybrid thread. It's mostly a square thread with a flat wall, but it has a slight taper to it and beveled top corners on the peak and stuff. The biggest problem with the square thread is it's hard to manufacture and be precise and do a good job. So they kind of come out with the Acme threads. It's my understanding that that's the reason they came out with the Acme thread with the slight taper and the beveled corners and stuff to make it a little easier to manufacture, yet still get the benefits of the flat walled threads. So there's a little bit of the differences between the different types of threads. The next thing you're going to find is screws and bolts and lead rods and everything are typically measured by pitch. And the pitch is nothing more than the distance from one thread to the next thread. That's your pitch. In this rod, it's a 2 millimeter pitch, which means if I take a micrometer or caliper or anything and I measure from the center of one or the edge of one thread to the same edge of the next thread, I'm going to get 2 millimeters. It's a 2 millimeter pitch. The US nuts and bolts, they have a pitch. I can't say in 30 years that I've ever heard anyone describe an American nut or bolt based on its actual pitch. In the US, what they typically describe these with is TPI, or threads per inch. If you get a pitch gauge and you put it on an American bolt, and say you have a 1/4 inch bolt and you put the pitch gauge on there, it's going to say 1/4 20. That's 20 threads per inch of bolt. Or 1/4 28. That's 28 threads per inch of bolt. That's the common terminology for American nuts and bolts. I don't hear them talk about the pitch, but they do have a pitch. In metric, they don't go by threads per distance, I guess. At least not that I'm aware of. They just go strictly by the pitch. And again, this is a 2 millimeter pitch. Okay, so that tells you part of what you need to know, especially when you're dealing with CNC equipment or 3D printers. But beyond that, a lot of people think that a 2 millimeter pitch means you're going to get 2 millimeters of travel. Travel is referred to as lead. Every screw has a lead. Now this is a single start lead screw. So for every revolution of this, rod, yes, it will travel 2 millimeters. But if I had a 2-start rod with a 2 millimeter pitch, then every rotation of this rod, you would actually move 4 millimeters. Because there are 2 actual threads intertwined on that rod. So for every revolution, you are moving 4 millimeters. And there again, on a 4-start rod, it's 2 millimeter pitch, if you have a 2 millimeter pitch, and it's a 4-start rod, then for every revolution of the rod, you will travel 8 millimeters. So you can see there's a lot of differences there. There's benefits and drawbacks to each. So now let's get into the difference in the starts. So let me see if I can illustrate what I'm talking about here. If I take a rod and I put a thread on it. Let me put a thread on it. Okay. And this rod, oh, you can see it there. This rod has this is a single start thread. Okay. And I'm going to wind this thread around this rod. Okay. So there you go. There is a single start threaded rod. Now this rubber tubing is 1 centimeter. So it's got a 1 centimeter pitch. There you go. Let's see if I can get that in front of the camera. There you go. It's got a 1 or 10 millimeter pitch. Let's go that way. It's got a 10 millimeter pitch. Okay. It's a single start. So for every revolution of the rod, you will move 10 millimeters. If you look at the rod at the end, you'll be able to see the single start. This camera's kind of hard to get used to. But anyway, you'll see one start. Again, 10 millimeter pitch, 10 millimeters of lead. So for every revolution, if you was to put a nut on here, it would move 10 millimeters every revolution. Okay? So now, let me unwind that. And let me add another start. Okay? So now I have a 2 start. And if I wind this around, now you will see on the end, you will see, sorry about that, you will see 2 starts. There you go. Okay, and if you looked at the end of a lead screw closely, you'd be able to see that it has 2 starts on the end. And 2 starts, same tubing. I have a 10 millimeter tube, so for every thread, you're going to see 10 millimeters, 10 millimeters, 10 millimeters. But for every revolution, I will have traveled now from black to black. So there's a 20 millimeter lead, 20 millimeter lead, 20 millimeter lead for every revolution of this shaft. Okay? Something else I want you to notice here, when I went from a single start to a 2 start, my thread angle changed. That gave me more travel per revolution. Okay? Keep that in mind. Now, let me go back. And now we're going to turn this into a 4 start rod. There's a 3, which I don't know if I don't think they make a 3 start, but they might. And there's a 4. And I know this is kind of cheesy, but I just felt like it might give me a colorful, easy way to illustrate the way this works. So now I've got 4 starts. And as they wind around the axle, it's a little bit harder to hold, but there we go. There's a 4 start. Well, that's kind of neat. I'm on a green screen, obviously, and I wasn't thinking, but this thread here that's gray is actually green, and it's removed the green. But you get the point. So now I've gone to a 4 start. Yeah, see if I can get her there. There we go. 4 start. And if you look at the end of a threaded rod closely, you would be able to see that it has 4 starts. When you cut it off, you'll see 4 starts there. So now we have the same 10 millimeter pitch, but now it is a 4 start. Okay, so if I turn it to right there and I show you, and we're starting out with this green / gray thread. Now for every revolution, we have 10, 20, 30, 40 millimeters of lead for 1 revolution. 2 revolutions, there's 80 millimeters of travel. So we just keep multiplying the lead on the screw, and every one of them I've shown you have had the same pitch. It's a 10 millimeter pitch on this. Okay, also, like I said, pay attention to the thread angle. There we go. To get that many more threads intertwined together, the angle has to change. It has to get less and less dramatic. So as it stretches out, we get more travel for every revolution. Okay, and when you're setting up the parameters in your firmware and things like that, you've got to know that. 1 revolution of the motor, I'll just say, I'll throw a number out there, 200 steps. Your motor has 200 steps per revolution. You have to tell your firmware that 200 steps of that motor equals 2 millimeter pitch, 2 millimeter lead, 4 millimeter lead, 8 millimeter lead. It has to be able to calculate that. Otherwise, your 200 step motor is going to equate to the wrong distance of travel on the machine itself. So you got to kind of learn that. Pay attention to the starts, the lead. It's more than just about pitch. Now, something else I want to tell you, if you're building a unit from scratch or trying to modify it for a certain purpose, lead screw is basically a form of a gearbox. It's got a gear ratio. If you have a single start screw, like I have here, 1 revolution is 1 thread. It's got a lot of holding power, a lot of strength there. It's also got a lot of torque from your motor. It's like a low gear in a gearbox. You have a lot of torque, but you don't have a lot of speed. If you switch to the 4 start screws, you have a lot more speed, but you lose torque and holding power. To give you an example, another illustration here, if I push down on this, this is a single start, it is going to have all kinds of strength to hold. And for Z-axis, that's what you want. You want a lot of holding power because you're fighting against gravity, and gravity's pulling down on your carriage, your hot end, your extruder, everything. So you would want more strength to hold that up mechanically, so you don't have to have you don't have to use as much torque out of your motor. Okay, it's going to require less torque out of your motor because it's a lower gear. It's got more holding power. I tried to find a good example, and this will have to do. But just as an example, let's see if you can see this. This is a CD drive, one that I've torn apart and was playing with. And if you look right here, you see this stepper motor with this lead screw. Okay, it's plastic. And look at the thread angle there, the groove angle. See, it's pretty laid out there. It's not a real tight. It's got a lot of lead to that screw. Okay, now here's the problem with that lead. Once you get to a certain point, this lead screw has gained. Let me see if I can come in from the other side. Can I come in from the other side? Okay, no, that's too hard. Okay, this lead screw has gained a ton of speed, and it's a CD drive. It's just got to move the laser around, so it's okay for this application. But as an example, because I've gotten all this speed, I've got no torque. Okay, that motor cannot hold it back. I can move it freely. There's almost no resistance. Okay, so for it to stop me from moving it, or stop gravity from moving it, if it had something heavy on it, at this kind of a angle, thread angle, you would have to have a much bigger motor with a lot more holding power, a lot more torque. So it's a trade-off. More torque, less speed. Less torque, more speed. All based on the angle of your threads, the number of starts in your lead screw. So these are all things that you need to keep in mind when you're building or modifying your units, and when you're configuring your firmware. You got to know all these details. So sorry I don't have a better example to show you, but I think you get the point. So there you go. There's a little information from me to you about pitch and lead, and hopefully this will help somebody out. That's my goal, is to just, help contribute to the knowledge, and I'm constantly learning myself every day. So I just wanted to see if I could maybe put together a little illustration that would help people understand a little bit. I know most of you probably already know all this stuff and it's second nature, but I'm sure there are people out there that have not picked up on this yet. So hopefully this helps. For me, I'm ready to move on to my next portion, and that's going to be building the corners so that I can start putting my frame together and get these threaded rods in. I'm excited. I can't wait to get this thing going. Hopefully my videos are starting to upgrade a little bit. I'm working on lighting, trying to get that better. I am trying to find better cameras. Right now I'm operating off the little camera in my laptop, and I have another overhead camera that I picked up at the Goodwill store. So and I picked up another microphone, so you'll notice a little bit of difference in the audio probably from the intro to the video, but as long as I make progress, if I get better every time, then eventually I'll get there. So that's it for now. If you like what you see and want to see more, or have any other ideas of things that you'd like to see, if I can do them, I certainly will. I sure would appreciate it if you would subscribe to my channel. Like if you like, dislike if you don't. Give me feedback. Help me make this thing better. Help me make it grow. Trying to work on some different logos. I'm trying to get that put together. All at the same time, I'm trying to get the parts and stuff squared away so I can get this printer built and actually get to printing. And also working on my makerspace in the basement and try to get that finished out so I can move all of this stuff. I'm actually setting in my bedroom right now. That's why I put the green screen up, so you can't see the mess. But in the background, you'll see that's Myrtle Beach from one of my vacations. That's just a picture I took down on Myrtle Beach in South Carolina. So wish I could live on the beach. But anyway, like, subscribe. If you have any desire to donate, there'll be links down in the description. I have a Patreon account, buy me a coffee, which reminds me, thank you, Anonymous, whoever it was. I have already had one person buy me a coffee. Please, if you do, let me thank you properly. Make sure you put your name and everything in there so that I know who has made the donation. It popped up on my screen and said Anonymous. So unless there's a way to find out that I haven't learned yet, because I've never done this buy me a coffee or Patreon before. Everything I've done has been PayPal, and I used to get monetized through YouTube. That was nice, but they changed all that, so we got to adapt to the times. But anyway, be sure and leave your name or username or something so that I can thank you properly. But whoever it was, Anonymous, thank you very much. It's well appreciated. I will see you again soon. Have a good day.